Okay, we're looking at exercise 11C from the first year mechanics textbook, and we're looking at question 5. So we've got a particle P, and we're given a function for its distance in terms of time, and we're asked to sketch a displacement time graph. So if you've got a graphical calculator, you can just whack that straight in. But this is a graph that we should be able to sketch. So it's a cubic, a negative cubic. So they will only ask you to sketch ones that you should be familiar with from your core maths. So let's think about sketching that. So we're question 5, and S is 9 over 2t squared minus t cubed. So whenever I'm trying to sketch a graph, I always want to factorize it. So I can take t squared out as a common factor, and that will give me 9 over 2 minus t in the brackets. So I've got a repeated root at t is 0, and a root at 9 over 2 or 4.5, and they have referred to 4.5 in the question. We'll come back to that. So if I was sketching the full cubic, so it's a negative cubic with a repeated root at 0 and a root at 9.5. So that's what the full graph would look like, but then they've restricted it to values of t between 0 and 4.5. So if I can, I'm going to try and just erase the bits of the graph. Oh, I don't want. Seems to just about be working. Okay, so that's actually the only part of the graph that works in this model. Okay, because they say it's between 0 and 4.5. So there's my sketch. And then it asks me to justify the restriction that t has to be greater than or equal to 0, but less than or equal to 4.5. Okay, so there's two parts to that restriction, so we must make sure we cover both of them. So t has to be greater than 0, well, because it does. So because time cannot be negative. Okay, so that may seem obvious, but we've got to explain the whole thing. And t has to be less than or equal to 4.5 or 9 over 2. Well, we've just got to be a bit careful here. So we can see why 4.5 is significant, but why is that a problem? So t can't be negative, but just be ever so careful, because actually on our graph it would have been fine because it was displacement time graph, but the actual model is the distance. So displacement can be negative, but distance can't be. Okay, so just make sure you specify that the issue is that distance cannot be negative. So let's put something in there. Okay. Right, so part C, find the maximum distance of the particle from O. Okay, so that's here. That graph is not going to be symmetrical, so I can't just go for the midpoint. But this is a really common feature in this type of question. As soon as they start asking about maximums and minimums, I'm going to want to differentiate. So if I'm differentiating, I want the expanded version. Okay, so if I differentiate, so when I multiply by the 2, the half will cancel. Okay, and I want a stationary point, so I want when that is 0, so I'm going to take 3t out as a common factor, the same stage. So I've got t is 0 or t is 3, and that all makes sense because I already knew from my sketch that there was a stationary point at t is 0, and t is 3. Yeah, that certainly seems like that could work, and I don't have to justify that t is 3 is the maximum. My sketch is enough for that, so I can clearly see that if I was interested in it, that would be the minimum displacement. I'm after the maximum. And then just be careful. Didn't just ask me to find t, it asked for the actual maximum distance, but this is a mock exam question, so it's worth 5 marks, so that's fair enough. So I'm going to go back to S, so I'm going back to this equation here. So S is 9 over 2, 3 squared minus 3 cubed, so that is going to be 4.5 times 9 minus 27, so 13.5 meters. Okay, and then another bit to this question. Yep, so find the magnitude of the acceleration. So So let's write out the displacement again. Okay, so I've actually, so this is going to be more differentiating. Sorry, I've got to change screens. Right, so this is going to be more differentiating. I have actually already found the velocity. I didn't refer to it as such, but obviously when I differentiated the displacement, or the distance there, I was finding the velocity. So if I want acceleration, I'm just going to differentiate that again. They wanted the acceleration at this point, and that's the point we were working on in part C, so that's when t is 3. So when t is 3, a is 9 minus 6 times 3, so a is minus, so minus 9. But they did ask for the magnitude, so do read every question really carefully, because if they just want the magnitude, they do want me just to then say it's 9. Okay, so obviously the minus tells me sort of that it's slowing down, but that's not what they asked for. They just asked for the magnitude. Okay, let's just check those. Yeah, I think we're good.